One. Today I will be starting with the second part of iron metabolism. In this lecture we will see the diagrammatic view of iron metabolism. How does it occur? So iron occurs in two parts, the heme part and the non-heme part. So the heme part is more absorbed. It is more absorbed than the non-heme part. So what is the non-heme part? It is the ferric iron which is present in the non-heme part. And the heme part is nothing but the ferrous state. So the heme is the ferrous state and non-heme is the ferric state. So now this ferric iron is converted to ferrous iron by an enzyme called as cytochrome B. So this cytochrome B converts the ferric iron into its ferric state. Once the iron is converted into its ferrous state, this gets transported by an element that is the divalent metal transporter. So as you can see, this is the intestine, this is the duodenal epithelial cell. This whole is the duodenal epithelial cell. So in the duodenal epithelial cell, this is the apex of the duodenal epithelial cell and this is the basolateral part. This is the basolateral part of the duodenal epithelial cell. So now what happens at the apex of the duodenal epithelial cell? There is a presence of DMT1. So what this DMT1 is? This is actually a divalent. It is a divalent metal transporter. What do you mean by divalent metal transporter? It is a transporter which transports the divalent elements. So what are the divalent elements? The divalent elements are the iron, the copper, the cadmium and the palladium, etc. So once this ferric iron is transported by the DMT1 into the apex of the duodenal epithelial cell, it enters into the duodenal epithelium cell in its ferric state. So from ferrous it is converted to ferric into the duodenal epithelial cell. So now what happens in this duodenal epithelial cell? In this duodenal epithelial cell, this ferric iron, either it undergoes mucosal shedding and the other one is converted into its ferrous state. So again the ferric iron is converted into its ferrous state and it travels to the basolateral part. So as you can see here, it has traveled to the basolateral part to a protein called as the ferroportin. So the ferroportin, it is the transporter. So now what happens is, this ferroportin, it transfers this ferrous iron to another protein into the basolateral part of the duodenal epithelial cell, that is the hepcidin or the ceruloplastin. So there is one more protein present on the basolateral part of the duodenal epithelium, that is the hepcidin or the ceruloplastin. So what are the two proteins present for the iron absorption? First is the ferroportin and second is the hepcidin. So second is the hepcidin. So you need to remember this because it is a very important question asked in exam. So first we will see who antagonizes ferroportin, means who reduces the action of ferroportin. So hepcidin antagonizes the action of ferroportin. So hence it decreases the absorption of iron. So hepcidin is an important component which decreases the iron absorption. So now here we will see what hepcidin does. Now there is a major difference between hepcidin and hepcidin. Hepcidin is something which causes the absorption and hepcidin din causes the decrease in iron absorption. So student gets confused during exam between the difference of hepcidin and hepcidin. Now what this hepcidin or ceruloplastin does? This hepcidin oxidizes the ferrous iron into its ferric state. So again here the ferrous iron, the ferrous iron which was on the basolateral part of the duodenal epithelium gets transferred to, or it gets oxidized into its ferric state. So you can see here that hepcidin and ceruloplastin is nothing but an iron oxidases. These are iron oxidases. They oxidize iron. Now we will see what happens next. This ferric iron, with the help of a transfer protein. Now what is a transfer protein? A transfer protein is nothing but which transfers iron. So now suppose this is an iron molecule. This gets attached to a transferrin protein. So this is a transferrin protein and it forms a complex like this. So this is the transferrin protein. This is transferrin. Now what happens is, once this is bind, this travels to the bone marrow. And where does it travels into the bone marrow? Into the erythroid precursor. It travels into the erythroid precursor. So now what happens is, on this erythroid precursor there are present of transferrin receptor. So as we have seen that here is the transferrin which is carrying the iron. There are transferrin receptors on the erythroid precursors. So this transferrin comes and it gives its iron. So it gives this iron to the transferrin receptor. Once this transferrin receptor has taken up the iron, so now this transferrin receptor has taken up the iron. This iron, by the means of endocytosis, what is endocytosis? Something that takes up, something that takes in the cell. So there is entry of this iron into the monocyte macrophage system. So the monocyte macrophage system, the iron enters and it is stored. So whenever there is erythropoiesis, the iron is released into this erythroid precursor and iron absorption takes place. So this iron absorption takes place, forms the ferritin. So it forms ferritin because it is absorbed in its ferric state. So you should remember that if iron is absorbed in the ferric state, it converts into ferritin. This is just as a learning point of view. It is nothing meant with ferric and ferritin. You people need to understand, so I have given it in a more simpler way, that it converts into ferritin and this ferritin is stored into serum. So whenever there is lab findings, whenever there is biochemical findings, we see the serum ferritin. So this serum ferritin is the marker of storage iron. So once again we will look at the overview. The non-heme ion from its ferric state gets converted into the ferrous state, and from the ferrous state, with the help of a divalent metal transporter, it is transported to the duodenal epithelial cell. Once it is transferred into the duodenal epithelial cell, it is converted again into its ferric state. Again into its ferric state, it is either shed by mucosal shedding, or either it is converted into its ferrous state, and this ferrous state travels to the basolateral part of the duodenal epithelial cell. Once it is traveled to the duodenal epithelial cell, it gets binded to the ferroportin. This ferroportin transfers it into the hepcidin. The antagonist of ferroportin is hepcidin, and this ferroportin transfers the ferrous iron to the hepcidin. Hepcidin causes the oxidation of the ferrous state into its ferric state, and this ferric state gets transferred by a transferrin carrier protein. And after the transferrin carrier protein, it goes into the bone marrow, into the erythroid precursor through the transferrin receptors. So once it is taken up by the transferrin receptor, it is taken into the monocyte macrophage system, and there it is stored, which on erythropoiesis is released and forms ferritin, which is present in the serum as serum ferritin, and which is the marker of storage iron.